What does a graph intersection mean for systems of equations? Imagine you have two lines drawn on a graph. When do you know they are connected in a way that tells you something special about the equations they representing? Well, the point where these lines meet is called the intersection. That point is very important because it shows the solution to the system of equations. A system of equations is just a group of two or more equations that share the same variables. For example, two equations with the variables and y. When you graph each of these equations, each one forms a line if they are linear equations. The intersection point of these lines tells you the values of x and y that make both equations true at the same time. If the lines cross at exactly one point, that point is the solution to the system. It means the values of x and y at that point satisfy both equations. This is called a unique solution. It shows that the system is consistent and independent because there is only one answer that works for both. Sometimes the lines might never meet. If they are parallel and run alongside each other without crossing, then there is no point that makes both equations true. This means the system has no solution. It is called inconsistent because the equations do not share any common point. Other times, the lines might lie exactly on top of each other. When that happens, every point on the line satisfies both equations. This is called infinitely many solutions because there are endless points that work for both equations. The system is dependent and consistent in this case. Graphing makes it easier to see these situations. It helps you visualize how the equations relate to each other. When you find the intersection point, you can directly read off the solution for the system. It's a simple way to understand what the equations are telling you. In summary, the intersection point on a graph shows where the equations agree. It reveals the solutions to the system. If there is one intersection point, you have a single solution. If there are no intersections, then no solutions exist. And if the lines are the same, then there are many solutions. This visual approach makes understanding systems of equations much clearer.